Hello and welcome to the functional group tutorial. Before beginning this tutorial, you should be able to recognize the following functional groups: alkenes, alkynes, arenes, alcohols, amines, ethers, aldehydes, ketones, carboxylic acids, esters, amides, and phenyl groups. In the first portion of this tutorial, we will go through a couple of the molecules together. During this time, you may have a list of functional groups near you. The first molecule we're going to look at together is aspirin. When looking at the different pieces of a molecule, we want to remember to keep the big picture in mind. So, for example, in aspirin, we see several carbon-carbon double bonds in the six-membered ring, which you may be tempted to classify as alkenes. But remember that the six-membered ring with alternating carbon-carbon double bonds and single bonds is classified as an arene, or more specifically, a benzene ring. In this molecule, we also see two carbons double bonded to oxygen atoms. This C double bond O, also called a carbonyl group, is found in many functional groups, so we must look at the bigger picture to identify the functional groups. Looking at the C double bond O on the right, we see that the carbonyl carbon is singly bonded to a methyl group and to an oxygen, which is bonded to a carbon on the ring. Therefore, this functional group is an ester. The other carbonyl carbon is singly bonded to the benzene ring and a hydroxyl group. You may be tempted to classify the hydroxyl group as an alcohol, but as it is bonded to the carbonyl carbon, it is part of the functional group classified as a carboxylic acid. The next molecule we are going to look at as a group is D-glucose. At the top of the structure of D-glucose, we see a carbonyl group again. And although you may be tempted to classify this functional group as a ketone, we need to remember that because there's no fourth bond drawn to this carbon, and the carbon has no charge as indicated by the absence of a charge sign, there must be a hydrogen atom attached to this carbon. Now that we can see this hydrogen, we remember this functional group is classified as an aldehyde. We can see several hydroxyl groups in this molecule. Before classifying all of these functional groups, we need to look at the big picture. As these hydroxyl groups are bonded to sp3 carbons and not carbonyl carbons or arene carbons, all of the functional groups are simply alcohol groups. Now we are going to do a couple of molecules to practice, so please remove the list and descriptions of functional groups that may be near you. I will place a molecule on the screen and then I will instruct you to pause the video. During the pause, use your knowledge and understanding of functional groups to classify them on the following molecules. When you are done with the molecule, unpause the video and we will go over them. The first molecule we are going to practice classifying is apetamin. Good luck and please pause the video. Great job, everyone. Let's check your answers. Remember, as we're classifying the different functional groups in the molecule, we want to keep in mind the big picture. For example, in the structure, we see several carbon-carbon double bonds in the six-membered ring. You may be tempted to classify these as alkenes, but remember that the six-membered ring with alternating carbon-carbon double and single bonds is classified as an arene, specifically a benzene ring. There is also one more functional group in this molecule containing the nitrogen. And although the name of the compound may have given away the name of the functional group, we still need to make sure it's correct. This functional group is known as an amine. We know it is not an amide because there is no double bonded oxygen on the carbon adjacent to the nitrogen. So the two functional groups are an arene and amine. The next molecule is norethindrone, a common component of birth control pills. Good luck and please pause the video. Welcome back. As we look at our molecule, we see several functional groups. We will work from left to right to make certain we don't forget any groups. Starting in the lower left-hand corner, where we find a carbon double bonded to an oxygen. This carbonyl carbon is also singly bonded to two carbons, and therefore this functional group is a ketone. The next functional group, as we work our way from left to right, is the carbon-carbon double bond. This is the only carbon-carbon double bond in this six-membered ring, so this excludes arenes. This is then classified as an alkene. Then we see the hydroxyl group attached to the five-membered ring. The carbon bonded to this hydroxyl group is also not part of an arene or a carbonyl group. Therefore, this is an alcohol. The last functional group we see is this carbon-carbon triple bond off of the five-membered ring. The only group we know with a carbon-carbon triple bond is an alkyne, and therefore, this is an alkyne. Great job. I have one more molecule for you to practice on, just as you did in the previous question. When you are done classifying the functional groups, we will go over the correct answer. Here is the last molecule, a precursor to L-dopa, which is used to treat Parkinson's. When you are done classifying the functional groups, please unpause the video. Good luck. Please pause the video now. Now that you are done classifying the functional groups in the molecule, let's go over the answers. We'll work our way from left to right during this to ensure we don't miss any functional groups. The first group we see contains an oxygen, which is singly bonded to two different carbons with no double bonded carbons on the adjacent carbon. This is categorized as an ether. As we travel down to finish the left side of the molecule, we see more oxygen atoms bonded to carbon. We see one is part of the carbonyl C double bond O, and the other is bonded to the carbonyl carbon. This makes an ester group. Both the ether and the ester are substituents on the six-membered ring with alternating carbon-carbon single and double bonds. We remember from earlier in our tutorial that a six-membered ring with alternating carbon-carbon single and double bonds is classified as an arene. More specifically, a benzene ring. When we look at our arene, we see there's another substituent on the ring. The last substituent has a carbon-carbon double bond. We know a carbon-carbon double bond is categorized as an alkene. There are two more functional groups at the end of this chain. The first is made up of a carbonyl carbon, C double bond O, which is singly bonded to a nitrogen atom. And therefore, this is an amide group. The last of the functional groups on this molecule also contains a carbonyl carbon. The carbonyl carbon is also singly bonded to a hydroxyl group, which makes this group a carboxylic acid. In review, this molecule has the following functional groups: ester, ether, arene, specifically a benzene ring, alkene, amide, and carboxylic acid. Thank you so much for watching this tutorial, and good luck.